let's try to figure out the helicity. Before that, let me revise what we have done in circular polarization basis. We have this kind of objective. This will be used in a momentum. Okay. So let me write it here. So we have this vector potential. So as a linear superposition of the variables. So summation lambda is equal to plus and minus. So you are two values of polarization, right circular and the left circular. Okay. So d3k by 2 by q. Okay. Then you are having so epsilon lambda. So this is the polarization vector. Okay. Then you are having this a lambda. So this is the amplitude for a wave. K dot r minus omega t and its conjugate. Okay. So then you are so this is the superposition principle we have studied in last lecture. So we have this very condition k dot epsilon lambda. This is equal to 0 and omega is equal to 0. Okay, so omega and k are related. They are not independent of each other. So this is what we have done in the last lecture. Clear? Okay. So you remember it? So let's try the angular momentum. Okay. So what is the definition of the angular momentum? Anybody? So let me write the angular momentum. Anybody? So angular momentum tensor, how we define? Huh? Anybody has an idea? So we write this as like x mu part of the latticing minus x mu, and you are integrating over a hypersurface ds. Okay, for x naught is so we are integrating over x naught equal to constant. So that means it's a 3-dimensional volume. Clear? So you remember this kind of formula? This we have done already. Huh? Remember it? Do you have an idea? What is okay? So what this x? So this is a hypersurface. Okay. So when I take x naught equal to constant, so what is that hypersurface here? So that will be simply 3 volume, is it? X naught equal to constant plane means the special coordinates. Okay, so it is simply equal to like this: J mu nu. Okay, so J mu 0 x nu. Clear? Okay, so now what is this very object? Anybody remember? So this is an energy momentum tensor, is it? Is it? Is this an energy momentum tensor? Okay, so what this object is, T nu 0, it's actually the 4 momentum vector. Clear? Or it gives you which quantity? Pointing vector, eh? Because energy momentum vector, 4 energy momentum vector is related to the pointing vector, is it? So this T nu 0 will represent you the pointing vector, is it? Clear? Okay, so you have you do you have an idea for this kind of formula? Huh? This formula we have already derived some time ago. You remember it? Okay. So let's, since we are interested in the 3 components, so this involves how many? Okay. So you are having this mu goes from 0 to 3 and nu goes to 0 to 3. It has temporal components as well. We are interested actually in the special components. Okay. So let me write the. So which actually give these special components will give the the angular momentum what we are interested in, is it? So angular momentum in three-dimensional space. Okay. So let's take this mu to be xi and tj0 minus xj ti0 dx. Okay. Got it? Simply mij and ij are what? Ij are 1, 2, and 3. Okay. So now let's write this tj. If you remember, this ti0, it is related to actually ith component of the pointing vector divided by c. Is it true? Is it true? Okay. So it's actually the, when you write ti0, it will actually give the three components of the momentum as well, is it? Because ti0 gives you what? Pi. Okay, so those are the three components of the momentum. Since we are dealing here with the fields, electromagnetic fields, so in that case, these three components will be same as the pointing vector divided by the c. Okay? Clear? Okay. So therefore, I can write this mij equal to 1 by c integration d3 over x. Okay, so xi sj minus sj x. Clear? Can I write it? Xi sj minus xj, sorry, xj. Okay? Now what is this pointing vector, anybody? So pointing vector is actually c by 4 pi e cross b. So let's take the ith component of this pointing vector. What is that? C by 4 pi. What will be that? So ith component of this cross product. Okay. So how much is that? C by 4 pi epsilon I j k e j b k. Okay. Is it true? Okay. So let's write it. Okay. So this is how we write. Okay. So this is these are. Now let me calculate. So let's calculate the kth component of the angular momentum. Okay, so let's do it this way. So you are having angular momentum tensor is given to you, is it? So let's say you are having mij is given, is it? So now I want you to calculate from this mij what is, let's say, Lx, what is Ly, and what is Lz, is it? From this I should be able to calculate. So look here. So let's take this mij, okay, for the time being, or like this thing. Let me write this M12. Let's start it. Okay, so what M12 will give me? Okay, look at this very form. Look at this very formula. Forget this thing. Okay, so I can write this as, okay, let me first write this mij again. Okay, for you people. So it is xi. What is tj0? It is the momentum, is it? So it is pj, is it? Minus xj, and then you are having pi. Okay, and you are integrating over dx. Is that true? Is it true? So what is your p mu? If you remember, p mu is 1 by c, I think. So it simply p mu is how much? P mu 0 d3 x. Is it? Is it true? So it's like this thing. So if you take now, let's say ith component, so then these are actually the densities. Samajh aaya? To yawa kat samajh? Because you are integrating. P mu, it's a density. You are integrating over volume. Okay. So let's take this very objective. Let's take M12. What is M12? X1. What is X1? That is simply X. What is J is equal to 2, is it? So that means Y, yeah? Let's take 1 is equal to X, J, okay, 2 is equal to Y, P is equal to Z, okay. So it will be X, P2 means PY minus, so Y, P, sorry, PX, is it? So tell me what is this object? What this object is? It is the z component of the angular momentum. Clear? So that means this m12 represents me what? Z component of the angular momentum. Clear? So how to write it? If you know mij, how to figure out, let's say, kth component of the angular momentum? Okay? So for that matter, what I will do, okay? So let's write kth component of the angular momentum. You need to, if you remember, you need to do 1 by 2 epsilon, let's say ijk mij. Okay, you just multiply it by epsilon ijk, is it? And contract over, let's say, I and j. So it will give you only the kth component of the angular momentum. Clear? So समझ आया? Clear? Okay. Any question here? Any question? Okay, so now let's write. Okay, let's write. So let's write this L1 for you people. So it's half of epsilon ij1 mij. Is that true? So what is that? How many values for this I and j will be now? Okay, so it will be, let's say, epsilon 321 m32 plus epsilon 231 m23. Clear? So is it true or not? So what is epsilon 321? What it is? Huh? It's minus 1. Okay. So it is half minus m32 plus what this object is? 1. So it is simply m23. Now you know this mij is actually antisymmetric. If you interchange I and j, this is actually an antisymmetric object, is it? So you interchange, let's say, 3 and 2. So that is same as what? m23 plus m23. So how much is that? m23, is it? So L1 is the x component, is it? So of the angular momentum, it is given by m23, means myz. Clear? So समझ आया? So that means this very formula gives you the kth component of the angular momentum. Okay? Or I can write it. Have you written it? Okay. Okay, or I will write, let's say, ith component of the angular momentum. I will put it like this: epsilon ijk mj. Simple. Okay? I have put I as a free index and jk as a dim index. Clear? So now let's write what is this mjk. So it is epsilon ijk. So mjk is actually d3 of x xj. Okay? So there is 1 by c as well. So what this is? sk minus xk sg. Okay? Clear? So it's 1 by 2c. Okay, integral the d3 of x epsilon ijk xj sa minus, what is it? So it's epsilon ijk xk sg. Okay? So what is this object? Can you tell me? So epsilon ijk xj sk. What is this object? Anybody? So it's simply cross. Okay, xj means jth component of r vector, is it? Tisha? Okay, so what it will be? It is simply cross product between r and s. Tisha, what is this object? This also the cross product between r and s. Now look here, you need to interchange actually the indices because you are having k here. Okay, so it is actually s cross r here. So sj and xk. So this will give you, okay, so this is actually r cross s and this is actually s cross r. So when you interchange it, what you will get? Minus r cross s. So minus and minus is plus. So it's twice r cross s. So 2 and 2 will cancel. So it is simply 1 by c integral g3 of x. So it is r cross s. Okay? So much more, but what it is? So it is actually the ith component of r cross s. Got my point? So the angular momentum. So or I can write this L is given by 1 by C integral d3 of x r plus. So that means it is related to the Poynting vector. समझ आया? So, have you got it? Everybody has followed it, what I have done? Huh? Okay. So now we know S. Okay. So we know the formula for S. What is S? E cross B, is it? Is it true? So let's put S in the form of E cross B. So or I can write this L is equal to 1 divided by C. So S is actually C by 4 pi. Okay. Integral d3 of x r cross. Okay. So it is E cross. Okay. So or I can write this L is equal to 1 by 4 pi. So d3 of x r cross. So now let's try, okay, let's call this as equation 1. So this is the angular momentum, total angular momentum carried by, let's say, the EM field. Okay? So let's calculate this cross product. If anybody is having any question, just tell me. Everybody has followed it? Huh? Okay. So let's take the cross product. By who is from Soho? Where from Soho? Which place? Okay, so now take this object. So you are having this R cross E cross B. Okay? So let's calculate its ith component. Okay? So let's calculate its ith component. If I calculate its ith component, it means I am calculating ith component of L. Okay? Because if I take Li, that, okay, ith component of this L means ith component of this thing. I need to calculate that. Clear? Okay. So let's calculate it. What that will be? Okay. Forget these are two things. So imagine this as only one term. So I will put it as epsilon I j k. Then R, jth component of R. Let's call that as xj, and kth component of E cross B. Okay, so it's equal to epsilon I j k xj. Now we need to calculate kth component of this thing. Let's write k l m. Okay, so it is equal to E L B. So this is how we calculate. Okay, cross product of these very things. Okay, so it is epsilon I j k. Okay, epsilon k l m x j E L. Okay, so BM I know. Okay, so we have this very objective vector B is equal to what? Curl of A. Is that true? Is it true? So now if I calculate mth component of this very object, so that means I will write curl of A, its mth component. For, okay, I have put B in terms of what? A. Okay, because what we know, formula for A, is it? Because we are doing the potential theory of fields, okay? So that's why we will keep everything in terms of A, okay? So instead of B, we will put it in terms of A, okay? And we know the gauge conditions are defined for this A, okay? So let's calculate this m component. So it is epsilon I j k, epsilon k l m, x j E L, okay? So what is this thing? So let me write M P Q, okay? So it's partial P A Q, okay? So you need to take care because this is a different derivative, it acts on A, okay? So you need to keep the order, you need to keep track of these things. Everybody followed it? Any question? Good. So let's move ahead. So let's take these epsilons. So I am having this very object. Let me write epsilon I j k. Okay. Let me evaluate these k. Okay, this thing. So I am having now epsilon K L M epsilon M P Q. Okay, so these things, then you are having this Xj E L, then you are having partial P A Q. Okay, so what this object is? Okay, tell me the formula. So you are having M is same, is it? So it is delta Kp delta Lq minus delta Kq delta Lq. Okay, so you are having this Xj EL partial P. Okay, so let's write it. Epsilon ijk. Since there is a sum of repeated indices, forget about this epsilon. So repeated index is what? P and Q, is it? So P and Q, they are repeated indices. J and L. Okay, so forget about L is repeated index. What remains is there? So in this very case, okay, forget this epsilon ijk. So what is the repeated index? P, Q, is it? And L, is it? So much more? K and J are free indices for this thing, but they are actually contracted with this objective. Okay, but for the time being, I will take, okay, I will ignore this objective, okay, and treat everything else. Okay, so let's evaluate. So let's sum over P. If I sum over P, this P will be replaced by K. If I sum over Q, Q will be replaced by L. So it is something Xj EL partial P. P will be replaced by K. Q will be replaced by L. Okay, got it? Okay, minus, now sum over Q, Q will be replaced by K and P will be replaced by L. So it is Xj EL, okay, partial L A. Okay, so what remains there? So these are the objects. Okay, so let's work out this. Let's put this in terms of the total derivative, this very term as well as this very term. Clear? So let's put them in. Since there is an integration, if you see L is defined, so there is an integral sign that I am not putting it. So there is an integral sign of this very objective. So for the time being, I will put them in terms of the total derivatives. Okay, call this equation second. Okay, so let's take this thing. So let's put. Okay, let's simplify equation second by bringing, okay, enter, okay, this way. So I will write this Xj. So let me write this partial K Xju. Okay, so you will appreciate it in a moment what I am doing. So I am taking the total derivative of this entire object. Okay, clear? So this I can write by product rule. Partial K Xjel, okay, then Al plus Xjel and partial Kal. Can I write it? So I am taking these two terms as the one term, Xj and X and E, and A as the second term, clear? And then do the integration by parts. Okay? So Samashavan. Now since I am having, if you, okay, so this L contains. So you are having in this L, this d3 of x and this object, its ith component, okay? So now if I integrate over volume, is it? So if I integrate over, okay, if we integrate over x, so then this total derivative, okay, then integration, okay, so let's write partial K Xj EL. Can anyone tell me what will happen to this very term? So what will happen to this very term? So you integrate over, it's a total derivative term. So you can count the, okay, make it a surface term by Gauss theorem, is it? So what will happen to it? So it will go to 0 because field is vanished at boundary. Okay? So do you feel so this will go to 0? Huh? Do you think so? Do you think so it goes to 0 on the boundary? Now look here, you can, since it's actually del dot something, is it? So it's like this very term. Okay, so let me write, so this very term, goes as some surface integral. Okay, so let's write some surface integral ds, okay, k, then you are having this x j e, okay, so there is an objective k in this thing, partial, okay, so simple, it is, okay, so el, simple, okay, so it's a surface integral. Do you think so? It's a surface integral. It's like this thing. So it's this very integral. So integral dv, okay, some gradient of a function. Okay, forget about something. So it is a divergence rather. So what you will get? So it's over surface ds dot f. Clear? So what will happen? So since this f contains what? These fields E and A, is it? So when you extend this s to the infinity, what will happen? So this will go to 0 because field is vanished at infinity. Okay, so that means this term will vanish at boundary. Clear? So it is a total derivative term, it will vanish. Okay? So what therefore you have? Okay, so therefore you have this objective. Since we are interested, this is the objective here. Okay? So it means this xj el partial k al. Okay, it is same as minus partial k xj al, but under integral sign, under integration over x, because this is only they are opposite to each other only under integration, is it? Otherwise not. Okay, because it is the only integration which makes this term to be 0. Similarly, now look at this very term. Okay, so let's call this as third. Okay, similarly, so now let's look at this thing. I can have now this partial L xj e L, okay, ak, that is same equal to, okay, minus times this xj e L partial L ak. So that means this very object is same as, you just shift this derivative on these two terms. Clear? Under integral sign. So समझ आया? Got it? Clear? Clear? So now let's try. Let's forget this very information, although I prepared it. So therefore I can write. Okay. So therefore we can have. So ith component of the angular momentum, what that is equal to 1 by 4 pi. Okay. Integral d3 of x. So ith component of this r cross e cross b, is it? So it's ith component. So how much is that equal to? So it's 1 divided by 4 pi integral d3 of x. Okay. Then you are having epsilon I j k. Okay, epsilon I j k. Okay. So you are having this very term. It's equal to this thing. So you are having, so it will come with a negative sign. So partial k x j e l and a l. So another will also come with a minus sign, but minus and minus is plus epsilon I j k. Okay, we are almost done. So you are having then, so partial l x j e l. Okay. Clear? So now let's differentiate this object. Okay, so I am having this ith component of this angular momentum. Okay, so that's 1 by 4 pi integration over d3 of x. Okay, so epsilon I j k. So now differentiate that. So you are having partial k x j. Okay, like this thing. Then you are having e l, and you are having a l also there. Okay, let me write this thing. X j partial k e l. Then you are having this a l. Another term. So it is a minus sign here. You are having minus sign plus epsilon I j k. Okay, then what you are having? Partial L x j. Then you are having this E k probably. So sorry, E L plus. Then you are having x j partial L E L. Then you are having this E. Okay, just differentiation by product rule. Huh? So these two things I am different. Now look at this very thing. You are having differentiation of x with respect to x, is it? What is that equal to? 1. But you are having j and k. So what this will give me? Delta k. Okay, so what this will give me? Delta Lj, is it? Clear? Okay, now look at this very objective. So you are having this partial L, E L, and E is an index over which there is some, it's a repeated index, is it? So that means this term is equal to what? Del dot E. Is that true? Clear? Everybody followed it? It's partial L, E L, and it is equal to del dot E. So what is del dot E in free space? It's equal to 0. So this term is equal to 0. Now let's look at this very term. So when you, since k is a summed index, is it? So when you sum over k, this k will be replaced by j. Okay, so you will be having, when you sum over this k will be replaced by j. So you will be getting epsilon I jj, is it? Did you get it? So what is epsilon I jj? Two indices are same, so it's equal to 0. So what it means? So this term is equal to 0. And this term is equal to 0. Okay? Now let's sum over, okay, let's sum over j. Here, if you sum over j, this j will be replaced by L. Because you are having delta Lj, is it? So j will be replaced by L. So I am having, so this L, ith component of this L, so it is integral d3 of x. So you are having, the first term is gone, the second term will be actually equal to minus epsilon I j k xj partial k E L. Okay? So let me write E L here. Okay? समझ आवा? Then plus, okay, you are having this epsilon I L k partial L xj E L. Okay? Sorry. So E, yes, there is an E k. Eh? So, sorry. It you are having E L and A K. Okay, so this is E L and you are having A K, and you are having A L is this object. समझ आवा? Okay. So now tell me what this object is. Anybody? So you are having L and K. So it means it is the ith component of this object, is it? So what that object is? E cross A. So it is the ith component of this thing. Clear? So now let's look at this thing. Okay, so look at this object. So these three, you are having epsilon I, j k, j and k, is it? So that means this object is what? R cross nebula, is it? So this very object, it's R cross nebula, but it's which component? Ith component. Okay? So since this derivative does not act on this AL, is it? So can I put this AL on this side? Can I put it? So I can put this object here. Okay? So that means, so what you are having, so the ith component is equal to 1 by 4 pi integral d3 of x, okay, minus AL and R cross nebula. Okay, it's ith component. Then you are having this EL, since this partial acts on E. So that's why you have to put it here, is it? Okay? Plus E cross A, its ith component. Okay? So now look here. So you are having A, L and EL, is it? So there is a sum over L. It's a repeated index, there is a sum over the repeated index. Okay, so that means this is a dot product between A and E. And that is actually, the dot product is sandwiched by this R cross nebula. So in other words, I can write this L is equal to, the angular momentum is equal to, like this thing, d3 of x, let me put this way, so AL, so R cross nebula, okay, EL, then plus E cross E. समझ आओ? So now this is the total angular momentum. So now if you look carefully at this very expression, the angular momentum is contributed by two terms. Okay? So there is a contribution coming from entirely due to fields. Okay? And there is a contribution due to this very object, is it? समझ आओ? So now look at the first term. First term depends on the how you choose the origin, because there is a r cross nebula, is it? So this is an origin dependent term. How you choose the origin of your coordinate system. So how you define the angular momentum? It is always with respect to some origin. Is it? If you are having r cross p is an angular momentum, you will define it with respect to an origin. Okay? You know it? Okay. So the usual angular momentum you always define with respect to the origin, is it? So we call that origin dependent angular momentum as the orbital angular momentum. Okay? So that means the first term contributes to the orbital angular momentum of the field. Okay? And the second term you are having only E cross E, A, it does not depend on the origin. Okay? So it is something intrinsic to the field. It only depends on E and A, is it? Rather E and B, A you can represent in terms of B, is it? You got my point? So that means it is intrinsically related to the field independent of the origin. We call this origin independent term as a spin angular momentum of the field. Okay? So that means this spin angular momentum contribution comes from the second term. Okay? And we are actually interested in this thing. Because since we are interested in calculating what is the helicity of the electromagnetic wave, is it? Clear? And helicity we define actually the projection of the spin along a given direction of the momentum. Is it? Rather in the direction of the propagation or opposite to the direction of the propagation. Clear? So we need to calculate what is the average value of this E cross A for the field we are taking the superposed waves. Okay, we need to calculate what is its average value, because ultimately you need to figure out what is the average value of certain quantity. Okay, so you got my point. Okay, so the first term you can say it is the orbital angular momentum, and second term is the spin angular momentum of the electromagnetic field. Okay. Okay. So now let's calculate it. Any question? Okay, so our spin angular momentum, L spin, that's equal to 1 by 4 pi d3 of x d cross. Okay, so let's try to calculate it. So, but we'll be interested in calculating its average value. So our interest is to compute time average L spin, okay, in the limit. Like this thing. What I mean by that, so we need to take so for a longer duration, okay, let's say you are having a detector, okay, and you through the detector you pass this electromagnetic wave. Now how you will get the result, what kind of polarization you are having? Okay, so you will observe the light going through the polarizer, let's say, over a longer period of time, is it? And at each step you will calculate what is the polarization you will get, and then you average over the values you are getting. Is it? This is the way you are doing the experiments, is it? So, you will not say, okay, so at let's say t equal to 0, you are having the light is passing through the polarizer, and you say the polarization is this thing, is it? So, but what you will do, you will allow the light to pass through the polarizer and wait for the sufficiently long time. Okay, so during that time you will observe what are the values you are getting, is it? And you average over those values for this duration of time which you are taking. Okay, clear? So much. So that's why we always are interested in this thing. So calculating the average of this objective. So this is how the experiments are done. So it means 0 to t, okay, dt else, okay. In the limit, what is t tends to? So let's do that. Okay. समझ आओ? Got it? Okay, so now what we need to calculate what is this E cross A. Okay, so what is our A? So let's start. So our A is equal to summation over lambda is equal to plus minus integral d3A divided by 2 pi cube. Okay, so then what you are having here, epsilon lambda, okay, K, A lambda K, e raised to I, K dot R minus omega t, then you are having plus epsilon star lambda K, okay, A star lambda K, e raised to minus I, K dot R minus omega t. Can you turn off this AC for the time? Huh? It's very cold, huh? So open up the doors, these windows. Okay, so what is our E? So E is simply equal to minus 1 by C partial A by partial T, because we are in which gauge? Coulomb gauge or the radiation gauge, where we have put phi equal to 0 and del dot A equal to 0. Is that true? So what is our gauge? Phi is equal to 0 and del dot A is equal to 0. So we sometimes call it as a Coulomb gauge or radiation gauge. So these are two names for. So now let's calculate this partial A by partial T. So now look here. So this is the term which contains the time dependence. So let's make a differentiation with respect to time. So it's minus I omega will come down, is it? But you are having minus already sitting outside, is it? So minus and minus will be plus. So now look at this very term. You are having minus and minus plus I omega. So I omega will come down and you are having minus here. So that means when you make a differentiation, second term will be the negative sign, is it? So I will write it simply as 1 by C, okay, rather I by C, like this thing. Summation of lambda is equal to plus minus. Turn, okay, open up the windows, so it will become hot otherwise. Okay. So you are having this epsilon lambda K, okay, so A lambda K. So there will be actually an omega, so that will put omega outside. So because from the differentiation omega will come down with an I, so I have put outside. So E raised for I K dot R minus omega t minus epsilon star lambda K, okay, A lambda star K, okay, E raised for minus I K dot R minus omega t, okay. So this is E, okay. समझ आवा? So now let's calculate this E cross A, this very objective, then we will take the average. Okay, now look here. So when I take the E cross A, so there is a sum over lambda and the integration over K, is it? So there is a sum over lambda and integration over K. Lambda as well as K, they are the dummy variables, is it? So in order to differentiate between the two, I need to put some, okay, so I will take this, let's say K, and let's call this as a K prime. So samajh aaya? You got my point? So otherwise these dummy variables will mix up. Samajh aaya? So now look here, when I put the E cross K, okay, so let's write this E cross A, okay, and there is an integration over X. So let's write. So what is that equal to? So it is integral d3 of X. So what I will put first? Let's say A, clear? So what is A? Sorry, E, it is this very object. समझ आवा? Then what you are having? You put with a cross with A. A contains the same thing, the integration over the same variable, is it? And you are having K is a dummy variable. So let's call this as K prime. So lambda will be as a lambda prime in order to distinguish between the variables. So समझो, when you are having this kind of situation, when you are having two objects, you are multiplying them, and if they have dummy variables in it, just relabel the dummy variables. Just distinguish between the dummy variables. Now look here in this case, so you are having this, A is actually the function of x and t, is it? समझ आवा? So x and t are not dummy variables. What is the integration on? K. So K is a dummy variable, but because of K and omega are related to each other by omega is equal to Ck, is it? So you are having this omega is equal to Ck, is it? So that means if this K is a dummy variable, omega will also be a. So let's put this K as a K prime. You put K prime and omega will be omega prime because you need to put a prime on it, is it? So for R and T, they are the free variables. So for this lambda, it's a dummy variable. You are summing it up. Huh? Okay, so for that matter, what I will do, so you are having IC here, okay? So, and look here, now let's put the cross product intact. Then I will put these variables. What is, you are having this as a vector quantity, epsilon, is it? So A is a scalar quantity. A is just the amplitude, is it? So what is the vector quantity? These polarization vectors. When you put the cross product, there will be only the cross product between epsilons and epsilons. So let me first put the terms together. Okay, so let me write this I by C. Okay, summation over lambda. So lambda means plus minus. So d3k. So let me write step by step instead of making any confusion. Okay, instead of confusing you people. Okay, so you are having this epsilon lambda k. Okay, a lambda k e raised to I k dot r minus omega t. Then you have minus epsilon star lambda k. Okay, a star lambda k e raised to minus I k dot r minus omega t. Okay, so then you are having a cross product like this thing. So crossed with, so let me write summation over lambda prime. Now I will use second lambda as the lambda prime, and let me write this as d3k prime by 2 pi q. Okay, then you are having this epsilon lambda prime k prime. Okay, a lambda prime k prime. Okay, then you are having e raised to I k prime dot r minus omega prime t. Then you are having plus epsilon star lambda prime k prime a star lambda prime k prime. Okay, e raised to minus I k prime dot of r vector minus omega prime t. Okay, so this is now the cross product between the two. Okay, so let's calculate the cross product. Okay, shall I skip many steps? Huh? Okay, so let's write the cross product. Okay, so for that matter, so have you written it? Quickly write it. So have you written this step? Okay, so let's multiply. Okay, so let me multiply. So let me write that step downstairs. So it is e cross a. So that's equal to, so integration over x. Okay, you are having I by c. So let me write summation over lambda lambda prime integration over d3k prime. Let me like this thing 2 pi cube. Okay, so then you are having this omega. Okay, so you are having this omega. So you cannot take this omega out because there is an integration of k and omega depends on k. Okay, so now let's write this epsilon. So let me write epsilon lambda Okay. So I will. Okay. So when I will forget about the argument for the time being. Okay. So to make things simpler. So samajh. So epsilon lambda means epsilon lambda k. Okay. When I put epsilon lambda prime, it means epsilon lambda prime k prime. Okay. So just to simplify things, epsilon lambda prime. Then you are having this a lambda. Okay. So let me write k a lambda prime k prime. So you are having e raised power I. So let's take this thing k and k. So it is k plus k prime dot of r minus I. Okay, omega plus omega prime t. Okay, then you are having minus term. So this multiplied by this thing. Sorry, it's plus. So you are having this epsilon lambda cross of epsilon lambda star, lambda prime star. Okay, then you are having this a lambda k. Okay, a star lambda prime k prime. Okay, so then you are having e raised for I k minus k. It's a big expression, but it's very simple. Minus I omega minus omega prime. It's a very simple expression, simple to multiply. Okay. So then you are having this term multiplied by this term. Okay, minus. Okay, so you are having epsilon star lambda cross of epsilon lambda prime. Okay, you are having this a star lambda k a lambda prime k prime. Okay, is it clear? Is it visible? Huh? Is it visible? Okay. So then what is there? So it is e raised for minus I k minus k prime dot of r. Okay, plus I omega minus omega prime t. Okay, then you are having the other term. So you can put actually the complex conjugation simply. So you can put this term, then the complex conjugations of the terms, but minus will not be captured. So you are having minus times. Okay, so minus times I will write the complex conjugation of this one. So that will come with simply, it will be minus here and plus here. Okay, so it's complex conjugation because that will ultimately go to 0 in a moment. We will see. Okay, samajh aawa? Okay. So okay, so let's write it. Complex conjugation. So what you will be having? So you are having epsilon star lambda cross of epsilon lambda prime star. Okay, a star lambda k a star lambda prime k prime e raised for minus I k plus k prime dot of r minus omega. Okay, plus I. So this is the cross product. So let's don't make noise. Okay. So from here it's very simple. Now look here. So there is an integration over x. Now what are the factors which depend on x? What are the factors which depend on x? Only the exponential factors, is it? So you are having this subject depends on x. This is an x dependent. Only the x. E raised for I k dot r terms depend on x. Okay. So I am having this very form. Let's integrate over x. So you are having d3 of x. E raised for I. Let's say k minus k prime dot of okay x or r. So that's equal to 2 pi q delta k minus k. Clear? So samajh aawa? You got it? So if I put here plus minus, here I put plus minus, so you put a plus minus here. Now what I mean by that, so if you are having k plus k prime, so it will be k plus k prime. If you are having k minus k prime, what it will be here? K minus k prime. So this is the formula of a delta function. It is the Fourier space presentation of the delta function. Okay? Clear? Now look here. Look at this term. So you are having this very term. So when you integrate over x, what you will get here? So you will get 2 pi cube times, so you will get actually 2 pi cube. Okay, so delta of k plus k prime, is it? समझ आया? And what is here in the exponential also? E raised power minus I omega plus omega prime t, is it? So from the x exponential you get delta function. From the t exponential what you are getting? It is same thing, is it? Now let's integrate over k prime. Let's integrate over k prime. What k prime will be? So tell me. So what is omega? Omega is equal to c times k. Tisha? So what is omega prime? That is c times k prime. Okay? So this forces k equal to, if I integrate over k prime. समझ आया? So if I integrate over k prime will be equal to minus k. समझ आया? So you replace by, let's say you replace k prime by minus k. What that will be? That will be again k. समझ आया? So that means if you replace, that will be simply equal to omega in this very condition. Got my point? So how? What is the factor? Then you will get e raised power minus r twice omega t. समझ आया? Got it? Everybody is following it. Look carefully. Okay, let me tell again. Now let's look at this very term, then you will appreciate it. Okay, look at this very term. So when I integrate this over x, so what I will get from this thing? So 2 pi cube, okay, e raised power, 2 pi cube delta, what is the, it is differential, is it? So you will get k minus k prime, okay, and you are having exponential, e raised power minus I omega minus omega prime t, is it? So now let's integrate over k prime. What this forces k prime to be same as k, is that true? So when k prime is same as this thing, which implies actually omega prime is same as omega, so what this will be? So this will go as e raised power 0. Omega minus omega prime, it will be 0. So that means this will go simply as 1. So now, so when you are, wherever you are having differences, so you will get, so these exponentials are gone, is it? So wherever you don't have, you have pulses, is it? Addition, is it? So you will be getting a factor of e raised power, so this will go as what? E raised power minus I twice omega t under integration over k. समझ आया? You people got it? Oh, समझ आया? Okay. Now let's forget about the terms which contains what? Which contains these signs. So what is the problem? Problem is with these exponentials, e raised power I omega. Since we are dealing with the average value. समझ आया? So now let's take that. Okay. So let me take the average of this thing. So you are having this g3 of x, and now take the average. So okay. So I will go do the average. What is the average? So tell me. So it is a time average. Teacher, is this the time average? Why is the time factor? Tell me. Why is the time factor? So in this very term, time factor comes e raised power minus this thing, is it? Minus twice omega t. In this term, there is no time thing, is it? So okay. So let's take the first term. So take first term. So first term means, so you have to take 1 by t, 0 to t, only the time argument, which is, so that's equal to minus I twice omega t. Teacher? So what will be the time average of this thing? So it is equal to e raised power minus I twice omega capital T minus 1 divided by, okay, so this t and minus I twice omega. Since omega is a positive quantity, is it? So it will go to 0 as t tends to infinity. So if you take t tends to infinity, what will happen? So this average will go to 0. समझ आया? Okay, so that means the average value of this very term vanishes. समझ आया? So now look at the fourth term again. So from the fourth term, what you are having? It's actually the conjugate of the first term. So you are having omega plus omega prime. You will get omega twice omega, is it? So what will be the average value of this thing? What will be the average? So it is again 0. समझ आया? So the average here is 0. Okay, so that means first and last terms do not contribute. Clear? Got it? समझ आया? समझ आया? Okay, now let's look at the third, second and third terms. They do not contain time dependence. That means you are integrating the identity. When you integrate over identity like this thing, So you are having 1 by t, 0 to t dt simply, because there is no time dependence, so it will be 1 by t. So t minus 0, what is that equal to? 1. If t tends to infinity, it will still remain 1. So that means only the non-vanishing terms are what? Second and third terms. Got it? Shall I write now? Okay, so you can take the screenshot if you like. Although it's recorded, yeah? So can I erase it? So the only non-zero contribution is due to the second and third term. Okay, so what is therefore this L average? So that's actually this thing, L spin, average of this spin. So what is that equal to? So you will be having simply now summation over lambda prime. So you are having then integration over d3k by 2 pi cube. Okay. Sorry, there is 1 by 4 pi as well sitting here. So let me write the formula complete. So it's 1 by 4 pi integral g3 of x. So average of this e cross e. So that's equal to 1 by 4 pi. Okay, and there is c sitting outside. So this is I divided by 4 by c, summation over lambda prime, both goes from plus to plus 1 plus minus. So that's fine. So it's integral d3k by 2 pi cube. 2 pi cube gets cancelled with that delta function, and d3k we are integrating over k prime. Okay, so what is here? So you are having epsilon lambda k cross of, so epsilon star lambda prime k. Okay, then you are having this a, okay, lambda k and a star lambda k prime. So now since k and k prime are in these terms same, okay, so then you are having this minus epsilon lambda star, okay, k cross of epsilon lambda prime k, okay, then you are having this a lambda prime k and a star lambda k. So this is the average value of this thing. Now we need to calculate what this object is. Clear? समझ आओ? So how much time is remaining? 3 minutes. Okay, so I will take 10 minutes. So to finish it. So we are almost done. We are almost done. So whose class is next? Huh? Which class? Okay, so let's stop.